Raul is the co-founder of an organization called Prismatic Labs, which has been doing absolutely massive work on Ethereum research and development. He's going to give you an update on the work that Prismatic has been doing on Sharding and Casper, better known as Shasper. Hopefully that's a thing now as well. Yeah, and I mean, I just have been on the sidelines watching some of the work these guys have been doing over the past few months. It's enormous. They've done as much to push Ethereum research forward as anyone in the community. So great. Thank you very much. And join me in welcoming Raul.
Do you have the clicker?
Yeah, of course.
Okay, cool.
Everything.
Okay, awesome. Oh, I was thinking to see electricity. Yeah. All right, testing, all good to go? Can I start? Okay, awesome. Hey guys, nice to meet you all. My name is Raul. I'm the co-founder of Prismatic, as Lane mentioned, and here to talk to you guys about what's going on with Ethereum 2.0, all the Shasper-related work, and what is to come. So just a little bit about us. So who is Prismatic Labs, right? We're a group of open source Ethereum developers that just assembled organically towards the end of 2017. We're basically all, just wondering the same question, like, hey, there's a sharding spec out there. Nobody's working on it. Like, why don't we just get together and build a repo and build a team and make it awesome? So we just started. We found each other all on like Reddit threads, on Gitter, on GitHub. Super cool how like things happen nowadays. And then we were able to just start hacking away on what Vitalik had put out there as an initial sharding FAQ. So if you guys have been following the latest kind of research and maybe have seen this post going around on Twitter and social media, there's recently been some talks about how layer 1 development versus layer 2 development should progress throughout the years. And the idea is that we've had protocols such as like HTTP, we'd had SNTP, we'd have these things that are public goods for the internet that have been around for decades. And they don't need extensive innovation, extensive maintenance going into them. They just work as expected. They allow us to build more complex functionality on top of what we have as primitives of the modern internet. And these things, are basically established and are there. Of course, we can upgrade them. There's HTTP 2 coming along. There are better versions, more secure versions of things. But in general, these things work. And at the end of the day, like when we're building applications on top of protocols, we just want these things to work at a low level and be able to build from there without having to worry about like these constraints, right? So, our job at Prismatic Labs, working on like Shasper and all the latest stuff, is to build a robust and scalable system that works as expected, basically. And then we want all you layer 2 folks that are working on interesting stuff to take the lead from there, building out either like execution engines, working on like other side chains, like maybe like shard-specific applications in the future, which we're going to get into in a bit. But so what does it mean to work on Ethereum 2.0? And what is the mental framework that we need to think about when we're going into this? And the general idea is that working on this means that you're operating under constraints, right? From the very get-go, like when you're looking at the initial spec, you see all these cool ideas about, oh, look, like, we're going to have all these shards, we're going to have like super quadratic scalability, we're going to have amazing like cross-shard execution. But at the end of the day, you have to ask the hard questions like, how is the current state of Ethereum going to migrate to Ethereum 2.0? How is gas going to work in this system? In particular, like what is the role of the proof of work chain in this example? And how can we just mesh all these things together? It seems like a massive hodgepodge of interesting ideas, but no book yet written down that cohesively ties all these things together in a way that's easy to digest and easy for developers to start working and implementing, right? So how did all this begin? So all this began where Vitalik had a sharding FAQ that's been out there for a long time, and basically explains like, hey, how can we get to this like next stage of Ethereum, this like this utopic vision of having like super quadratic scalability and like maintaining security, right? It's a really good overview. If you guys haven't checked it out, highly recommend this. But that's essentially how we started. There was a decently put together spec. It seemed like it was thought out pretty well. So, as an implementation team, how can we turn this into something tangible? How can we make sure that we work around what the current system needs and build something that's actually useful and can be deployed to production in the future, right? And at Prismatic Labs, we care about building something that eventually everyone in this community will use, and that it's actually going to be an upgrade to the system, rather than just like a toy implementation or just playing around with this. So earlier this year, everyone that was working on like sharding and Ethereum 2.0 assembled in the sharding research gathering in Taipei, where we basically talked about all this stuff. And I'd say that we probably came out with more questions at the end of the conference than we came in with, mostly because there is so much to figure out, right? It's so difficult for a single team to be able to take on the entire initiative of Ethereum 2.0, all the way from like the consensus layer, the protocol upgrades, cross-shard execution, state migration, security. We need as many minds as possible working on this sort of stuff. So how did the spec evolve? I'm going to go through a little bit of history here, and then I'm going to go into some of the current details of the spec and what we've done so far. So initially, the idea was that to maintain compatibility with the proof of work chain, we could actually deploy sharding as a contract. So the idea is that we would have this smart contract that we would deploy on the proof of work chain that would manage the entire system of the shards. So that is, you would have like shards that exist as like these separate entities, like kind of like as little side chains of sorts. And essentially, people called proposers would submit blobs of data, basically Merkle roots, to the sharding contract. And because that transaction is mined on a proof of work block, you basically get the proof of work probabilistic finality that you obtain right now of an Ethereum transaction, right? So this is a really interesting meta way of getting to where we want. We're basically leveraging what we currently have to build up this even more complex system on top of it. And that leads you to the question of, okay, how can we go from this into something like, like a super quadratic system? How can we deprecate the main chain? How can we do cross-shard transactions here, right? What about miners? Can they like try to front run us? Can they try to like censor things? Can they mess things up in the sharding system? And the answer to those questions are yes, those are valid concerns. If you try to leverage Ethereum this way, like you'll run into some issues. Additionally, like Casper and proof of stake was originally going to be done through a mechanism like this. So we were going to deploy a Casper contract on the main chain that would manage the entire proof of stake system and do the whole checkpoint epoch system where you would get finality on the main chain. So what are the issues here as well? Like people are wondering, am I going to have to pay gas costs for these like simple Casper transactions, right? Am I going to have to pay gas costs for sharding transactions? How does Casper and sharding interact? Are the two contracts going to talk to each other, right? So we get into this huge mess, and we start to wonder the natural question, wait, can Casper and sharding kind of come together? If we're doing them as this kind of this hybrid system where we have a contract deployed and then we manage things through here, why don't we just kind of merge the two in some interesting way that avoids all these constraints of dealing with gas costs and like EVM compatibility, right? So as I mentioned before, like if we try to do these complex systems as contracts on the main chain, we run into the issue of gas. We run into the issue that like whenever we want to upgrade the system, we have to do a hard fork on the system, and this can be manipulated at the whims of the miners. So we're actually better off building Ethereum from the ground up. And the good thing here is that we're not entirely starting from scratch in terms of how we're going to deploy this. We already have a main chain that we can leverage for finality reasons and for security that we already have. Right? And from here came the idea of a random beacon sidechain. I'm sure you guys have probably seen this around, around Twitter, around latest ETH research posts. But what does this really mean, right? Like, what is the motivation for doing this as a sidechain? And like, what is the idea of a random beacon, right? So, as I mentioned before, instead of having this contract deployed on the proof of work chain, we would instead create this sidechain that's going to be a full proof of stake chain, like no BS. It's going to be synchronized with the current proof of work chain, and it's going to be the heartbeat of the entire sharding system, right? So we saw the POA guys talking earlier in the panel about how sidechains are so powerful. And we believe the same. We understand that we can actually leverage what's already there in the main chain. We can leverage the proof of work algorithm in the beginning to onboard people into this sidechain. And then we have basically a system we can start from scratch. So this means we can define an entirely new chain for Ethereum 2.0 that has full proof of stake with cash per FFG, manages the entire sharding system, has its own notion of like state execution, and has its own notion of built-in pseudo-randomness that I'll get into a bit later. But ideally here, we eliminate all those design constraints that existed before, right? We don't have to limit ourselves to being worried about, oh, what's gas going to look like? What's going to happen with this? How can we do this without breaking backwards compatibility? Well, we're saying, screw it. We're only going to use the proof of work chain for synchronization and for people to deposit stuff and join this network. But Ethereum 2.0 is going to be its own new thing from scratch, right? And that's, I think, really exciting. It gives us a whole realm of possibilities. And here's this amazing diagram by Xiao Wei from the Ethereum Research Foundation. So the idea here is that you have this main chain that we currently have, and kind of linked to it in parallel, you have a beacon chain that basically stores main chain proof of work hashes. I know this diagram looks kind of crazy, but it'll get a little bit simpler. And from here, we allow the ability for basically shard chains, which are these constructs that split the state into partitions, to coordinate their data and be able to have the beacon chain be able to reach consensus on what canonical shard chain data should be. Right? So philosophically, one can think of shard chains as a coordination device for essentially how a beacon chain is going to reconcile them and determine what is canonical or not. One way I like to think about sharding, and the reason why we can leverage blockchain in such a way, is in terms of compressibility of information. Right? So imagine that inside of a block, instead of storing like the entire, the entire set of transactions, like storing like a transaction root, storing like a state root, instead of that, what if you could store a simple message that says like, hey, this is what happened on shard 5. These are the validators that like signed these blocks. Here are the Merkle roots of the latest transactions. And you can compress all of this into basically a short form message that summarizes the entire state of a single shard in a point in time. Right? And this is a very small amount of information that will need to be put inside of a block. So realistically, you're able to compress all this information that's occurring and do so in a way that's secure while leveraging something like the finality of a proof of stake system and the security of the main chain system. Right? So let's go step by step. So like how does Ethereum 2.0, how is it going to work? How can you guys join? How are we really going to leverage this main chain? Right? So the first thing we're going to do is we're going to be deploying a contract called the validator registration contract on the main chain. So it's a simple way where you guys can deposit 32 ETH. And what's going to happen then is that the beacon chain that's going to be constantly listening for logs on the main chain is going to be like, hey, look, somebody registered and put in 32 ETH. So now we're going to queue them up as a validator for the beacon chain. Cool. So we can verify that you're the real person using your public key. And from there, we basically queue you in. So what happens is that the beacon chain has this notion of cycles. And cycles are basically, number of blocks, number of slots of where blocks can happen. So once you reach a new cycle, that's when you become an active validator in the beacon chain. So you can do some interesting stuff, like you can start actually connecting to shards, you can start packaging transactions and data into blocks and start proposing them and doing interesting things here. So what's an important constraint here? For those unfamiliar, a big constraint that we have in sharding, regardless of the whole sharding manager contract idea, is that we can't allow people to know what shard they're going to be assigned to in advance. And by people, I mean validators. So if you're the person that's going to be proposing a block on a shard, ideally, we don't want you to know that, hey, you're going to be part of shard 5 always. That allows you to do some interesting things, like you can do some interesting attacks, you can do cartel attacks, you can do some interesting look-ahead situations here. So, if you split basically a security of the Ethereum network into n partitions, you're going to get a certain decrease in security proportional to that, and we want to prevent that. That's why we do this pseudo-random shuffling, such that you're only going to know very few moments in advance what shard you're going to be assigned to, and which one you're going to have to be performing your block proposals in, right? So That's why we call this a random beacon chain. It has a built-in notion of pseudo-randomness in it, and we're leveraging interesting tools such as like RANDAO mechanisms, which are a cool way to like generate randomness through a committee of people. We're using BLS signatures for like signature aggregation. And what's interesting here is that we have this enshrined notion of randomness that we're then able to use for Ethereum 2.0. And that can be used inside of dApps, that can be used inside of like the contracts that are going to exist on this chain. And it's in particular, it's going to be used to select validators, right? So say that a new cycle begins. So say it's like, it's like slot 64 in the beacon chain. So all the people that deposited 32 Ether are now going to be selected and say, oh, you're going to be on like shard 1, you're going to be on like shard 5, and here's when you have to propose a block. So you get a very limited time frame to do so, right? And here's what happens. So what do validators do in Ethereum 2.0? So validators are committees that essentially they reconcile what happened inside of a shard, and they produce a block for the beacon node. And that block is going to be signed by other validators known as the testers. Right? So for example, you can see here that a validator is going to package transactions into a beacon block. They're going to put in all the block. They're going to put the block hash of what happened in a shard and possibly other fields. And they're going to be reconciling, okay, who signed this, right? One of the major bottlenecks that existed in like Casper FFG and like basically all the proof of stake systems came down to like signature verification. And the bottlenecks, like, you're going to have to verify so many signatures in such a short span of time, and like, how can we really fix that constraint? So one of the things that we're leveraging is like something called BLS signatures. For those that are unfamiliar, it's basically a way of like doing signature aggregation into a single signature that then somebody can verify, right? And this is something that's being used by Definity, and it's something, it was created by Dan Bonet and Professor Lin and Shaham. So here is an example of what I was just talking about, right? So you're going to have all these people signing beacon blocks. How can we make sure that like the verification of those signatures is efficient? So that's why, if you guys follow the research threads, we talk a lot about BLX signatures, like signature aggregation. And here's what it really means. It basically means that like I have all these signatures from these validators. I want to be able to aggregate them into something that like Bob up here is only going to verify once. And that's very effective. That's very nice. That allows us to stay within the constraint of like people being shuffled very frequently across shards and having the time between like block proposals on the beacon chain be very small, right? So you guys might be wondering, okay, this is interesting, this is cool, but I still don't see how this really gets us to scalability. And I'm going to be talking about scalability in like 3 particular ways. One of the ways is horizontal scaling. So if you guys know about database sharding, it's a basic idea that you can partition a database into like n shards, and automatically you get some sort of linear factor of being able to scale like that. What's interesting here, aside from that, is parallelizability of transactions. So in Ethereum in particular, a node has to process, like if you have 10 transactions coming into the network, you basically have to process all 10 of them. Every single node in the network is going to have to process all 10 of them in a certain order. And what we can do with this is allow for a greater split, allow for parallelizability, and allow people to not have to download the entire state of the network to be able to be in sync. That's why it's really cool that Ethereum 2.0, one of the major goals is that you're going to be able to run it on your smartphone. You're going to be able to run a validator node or even a full beacon node on your smartphone. An interesting fact, like the beacon state is actually very small in size relative to like what the Ethereum state would be. So that's going to be something really interesting. And that's how we think about scalability and what the constraints are. So we're very excited about this, if it's not very clear. So how do we ensure that data is kept around, right? So, I mentioned before that validators need to be basically assigned to shards, and they get reshuffled every so often. So for example, okay, I got assigned to shard 5, but boom, now I have to switch, and now I'm like in shard 6. Like, what incentive do I have to not just like, wipe my shard chain data folder and like start a new one from scratch, right? Well, the way we do this is we enforce something called a proof of custody, which is basically a crypto economic scheme where we enforce these validators to maintain the shard data that they download for a certain amount of time. That's called a proof of custody challenge period. And in that time, they can be challenged by other validators. They can be like, hey, you're supposed to be holding on for to shard 2, right? and like, you know, if you respond like, no, I don't have anything, then obviously you're going to get your deposit slashed in some way or another. So it's very, very counterproductive to not do this. And that's still something that has not been well defined in the spec. So there's some interesting constraints here, like how can we keep the proof of custody challenge period like small enough such that people don't have to store that much data, but like also not big enough such that, you know, like, so we have the other problem basically. We don't want validators to be storing so much information. Right? So what does the research not cover? And that's something that we've been like really, you know, dealing with at Prismatic Labs since we started. And the most interesting things are like what's going to happen to existing state, what's going to happen to cross-shard transactions, and obviously I get this question a lot. And you know, the way I think about it is that look, like cross-shard transactions are something that come at a higher level than the consensus level of the beacon chain. And that's something that you're going to be able to like reason more about once you have a better idea of how the beacon chain is going to function and how you're going to be able to like coordinate across shards. Right? Right. I'll be getting to questions in a bit. Yeah. So there's no way any team could do this alone. You know, aside from us, there's the other teams. The Ethereum research team is working on a Python implementation, and there are other teams as well, like working in Rust, NIM, Java, and us, of course. So there are Ethereum 2.0 bi-weekly implementers calls that I highly recommend you guys to like check out, or at least check out the notes. And you know, at Prismatic Labs, we're building a production-ready client. So what does this mean? Basically, you know, we're choosing a battle-tested like build system that's in production at Google. We're using a top-notch like maintained P2P library from Protocol Labs, which is like used by IPFS, which is libp2p, and we're using the best-in-class RPC framework, which is Google's gRPC. So we also want to maintain a very welcoming and open source contribution ethos. So we want to make sure that like knowledge of Ethereum 2.0 and scalability is not restricted to like 2 people on our team. That basically newcomers that basically want to help, they have all the tools needed to be able to contribute as much as we do and get excited about this as much as we do, right? So what have we done so far? And we'll have a lot more updates for you guys by DevCon, so get excited. So we basically have right now a full beacon chain that synchronizes with a proof of work chain node. We have beacon node P2P via like local DNS with Gossip Sub. We're able to interact between a validator node and a beacon node. We have all the validator shuffling and registration contract functionality done. And here's some like, you know, some code running. So yeah, so we have a beacon block simulator. We implemented all the Casper FFG functionality, and we have state transitions going on. And we also have an end-to-end system basically for advancing the beacon chain from Genesis. So the idea is that, you know, in a few weeks or so, like as things mature more, it'll be easier for you guys to be able to spin up a beacon node, get a validator node running, have it, you know, generating some test blocks, and advancing the chain from Genesis, just like you would a Geth node in dev mode right now. So yeah, so this is our team. If you guys want to get in touch, check out our repo. All that stuff is there. Just like a Prismatic Labs, we have a bi-weekly update that goes out on Medium, so highly recommend. Yeah, thank you guys. I'll went a little bit over time, but thank you.
Thank you, Raul. That was awesome. Yeah, I don't think we have time for questions, unfortunately, but if people want to find you and communicate with you, what's the best channel to do that?
Yeah, I'll be walking around, so I want to meet all of you, like if I can, and yeah, get in touch via Twitter, contact us on Prismatic Labs' website. There are lots of ways, but yeah, sorry about that. Didn't leave time for questions.